Okay, so let's start. Hey everybody, I'm Tomas. I'm from Play7, a company with more than 10 years of presence in the mobile industry, and I've been working on already here for 7 years, working on the backend of most of our multiplayer games, among other things. So we do games, and I also play games. These days, I spend most of my time in Divinity Original Sin 2, which is my favorite genre, role-playing and fantasy games. And I can't wait for Baldur's Gate 3 and Cyberpunk. So today, I'll show you there's also a different story to our most famous Tamagotchis and runners. So what are we talking about? Most of you are already familiar with our Talking Tom and Friends brand. For those who aren't, I'll present shortly and tell you a bit what's behind the idea of adding multiplayer functionality in our games. We'll see how we reused technologies and applied it to our other games, how we try to appeal to a more mature audience with our mobile game, and we'll finish with a sneak preview of our future plans. Let's start at the beginning. Who we are at Outfit7 and what we do. So a short video to break the ice.
We're Outfit7. We've been making games for 10 years. Our apps have been downloaded 10 billion times. Our videos have 40 billion views. And our characters have been poked, slapped, and sent to the toilet too many times to count. But it wasn't always like this. Let's take a trip way back in time. All the way back to... whoops. To 2009.
Okay, that's it. We won't get back 2009 because that's too far, but a little bit later. So Outfit7 is entertaining the world with mobile games, animated series running on YouTube and TVs in multiple languages. We have more than 20 games, mobile games, and over 14 billion of downloads. At the time I started in 2013, My Talking Tom was a huge success. And we just released My Talking Angela. I remember my first winter team building was My Talking Angela themed. We had games across all the locations we were having the team building that resembled the mini games from the game. And it was really awesome. So our virtual pet simulations are doing great. So if you check the app stores, you can now find also My Talking Tom 2 and My Talking Tom Friends, where you can get to interact with all of our characters. And we also have runner games, Talking Tom Gold Run and Hero Dash. So all the games I mentioned so far are casual and accessible to all ages. But there is also another story behind our games. Our strategy is to reach a bit wider audience with each game release, adding features that would attract new players or friends of the kids that grew up with our games. And what better option than to add a bit of multiplayer in our games? So we started Mars Pop. We developed our take on a classic bubble popping game where two players could battle against each other. We started a story for a new brand targeted at an older audience with space themes and personal robots. The story was that these characters would eventually go to Mars and build an environment over there. The brand, unfortunately, didn't make the breakthrough we wanted, so we went back to what we knew worked best. So our Talking Tom brand. For the same game, we redid all the assets, used our most popular characters from the games and series. We released Talking Tom Bubble Shooter. The game, like Mars Pop, is a classic bubble shooter. Some of you might know Bust a Move from the arcades or from Super Nintendo. The game is perfect for a mobile platform, and it has a cool multiplayer potential as players affect each other during gameplay. The more bubbles you pop, the more trash you send to the opponent, and we added superpowers, slime, lightning, lasers. A player would unlock these superpowers as he progressed through the game and then use it in battle. Even if we implemented most of the features for Mars Pop, we then perfected it for Talking Tom Bubble Shooter. We wanted to make a multiplayer infrastructure that is high performance, scalable, accessible all over the world. Our first implementation was actually using the backend infrastructure provided by Google Plays and iOS Game Center. At the time, Google and Apple were promoting their multiplayer services, but by using them, we would lose cross-platform play. And this was very important for us because players from iPhones and Androids would just play between themselves. So after a bit of research, we stayed on Google App Engine for common games configurations and endpoints to retrieve a list of match servers and turn servers for the multiplayer features. And we tried out Google Kubernetes running Vertex for the match servers, for matching players, and turn servers for providing UDP communication relay for player communication when the players cannot connect directly with their phones. So from our previous games, we are already familiar with Google App Engine. We just needed to add multiplayer functionality. So for the matching service, we opted for Vertex. I have a framework that allows to write event-driven application and is suitable for input, output, and CPU-heavy processes that require parallel computing. At that time, it was the ideal choice for creating lightweight, high-performance microservices. So how does everything work together? The server list and match and turn server is obtained to Google App Engine Web Services. This is a configuration request, and the turn server list is then optimized based on the client's geolocation. The client sends a request to the match server located behind a Google load balancer. The match server then finds an optimal match and sends the match info back to both clients. This is done through WebSocket. The clients connect and start a match. The connection can be direct between two phones, or if one of the clients is behind a NAT, they go through our turn server. All the specified component can be enabled, disabled. We can add more match servers. We can add more turn servers to support multiple traffic, and each of these components can be configured within each Vertex cluster node. An interesting part of the backend infrastructure was were the matching verticals, the main component of Vertex. There we implemented there an ELO matching strategy. The ELO matching strategy is used in for chess games, for example, making this our first competitive game. And this was the first time we were struggling with cheaters. That would affect other players' experience in the game. For example, hackers would play on two phones between themselves to boost their rankings. They would disconnect before losing, or disconnect against one opponent that had all powers unlocked. Another thing is how the game mechanic worked. One multiplayer match would cost you 1 energy. Energy would eventually replenish during the day. We had a feature where you could send 1 energy a day to your friends. And we were really surprised when Facebook groups would pop up where random users that didn't know each other in real life would connect to get almost unlimited energy, allowing them to stay in the game even more. So in the end, Talking Tom Bubble Shooter was for us a success at that time. Now we have the infrastructure. We have a backend infrastructure, and the client team implemented a library that can be integrated in other games. And we had the perfect game to use it again, Swamp Attack. It's a bit a more mature game. Unlike our virtual pets, this game has guns, swamp critters, and it's just a little bit more violent. The multiplayer feature was 1 against 1, shooting birds, collecting eggs, deploying monsters against the opponent. So we had the backend infrastructure in place. The client integrated our multiplayer library, and the game was almost ready. Well, the gameplay had to be adjusted to the multiplayer features, but the backend was ready. The matching algorithm was the same, with just different user segmentations. So that was it. Implement a new matcher, check that the infrastructure can handle the extra load for the new games, for the new users, and play. With little effort, we added new life to an existing game. And the feature was really fun. We saw it already during company tests. People that were not that interested in the bubble shooter mechanic really enjoying Swamp Attack. Another game that we did was Talking Tom Camp, developed by the same team as Swamp Attack. We know our brand is strong, and at that time, Clash of Clans was still very popular. So we tried with our version, with water balloons instead of bombs, instead of guns, and we tried to make it fun for a younger audience. So we had 3 houses. We had our characters as champions. So the infrastructure for this game was a bit simpler, not because we had to implement less stuff, but there was no real-time multiplayer, but still a complex turn-based logic. Running again on Google App Engine, the backend was taking care of the opponents, so prepare a valid pool of opponents based on the power levels, on troop numbers, on upgrades, on buildings. The backend was also sending notifications for users under attack. So like in other games, when somebody attacks you, you get a notification on the phone. When the attack is over, you get the notification whether you won or you're lost. The backend was also handling cheaters, resource buildings, in-game currencies, preventing cheaters, I already said that, storing and serving replays. So unlike our casual games, as My Talking Tom or My Talking Angela, the game logic was fully on backend. So the backend was the authority. And this was our most complex game logic by far at the time. But let's move on. We want to implement more multiplayer features. We have now 1 against 1. We had camp that wasn't running on the same infrastructure. We want to build a multiplayer arena. So our next big game, My Talking Tom 2, was being developed, and we needed a mini game to keep users engaged when Tom was clean and full of food. It's Tamagotchi game, you have to take care of the cat. We implemented a multiplayer game where Tom's pet would be the player's avatar. In a multiplayer arena, the pet would eat space bubbles, defeat other players, and grow the longest trail on the server, similar to Snake or Slither, if you know it. It was perfect for integrated with the My Talking Tom features. The same skin of the pet would be used for the trail in the game, and power-ups picked up in the minigame would then be reused in the main scenes. This time, we couldn't just add a new matchmaker like we did for Swamp Attack. So our backend team started working on an arena-type matching server. Again, we have Google App Engine that provides the clients with the location of the match servers. the match server matchmaker that redirects the clients to the correct game server based on the user's rank. This time it was more simple. It was just easy, medium, difficult this time, because it's again a different demographic for our game. The new challenge was to have arenas with 50 to 100 concurrent players and make sure new arenas can spawn when one arena is full, and a matching mechanism that could sort these players in the arenas without errors. So the game server is running on Google Kubernetes engine, which provides an automatic scaling options. We just needed to configure the trigger point. How many users must be online to spawn a new server, a new instance. For example, one arena is already at 80% capacity. We have 80% of real players, and we add some bots as trail. The bots add a little bit more fun, and the users that are not so familiar with the game can just grind them to grow bigger and have more, enjoy the game more. So the arena is at 80% capacity. Let's spawn another arena, fill it with bots, and spread the real players evenly between the two arenas. So once your space trail is destroyed, respawn in the new arena with less players. This way the games run smoothly without hiccups caused by the infrastructure. At our peak time, fun fact, we had around 15,000 concurrent players. So right now, if you check on Steam, that's the same number as the average Red Dead Redemption 2 concurrent players online playing multiplayer. This time on Space Trails, we didn't have a complex matching algorithm like ELO, just arena based on 3 difficulties. So our inexperienced audience wouldn't get frustrated by more engaged players. We use the same Vertex technology for the matchmaker and Kotlin in a Docker container for the game servers, where the actual game runs. This game was also, for this game, the backend was also the authority. And both were deployed on Google services. We did stress tests for the server infrastructure to see what's the maximum load one instance can handle. And as a fun fact, we had an A/B test running. So an A/B test is when you want to test different behavior to see which feature is more fun for the user, more engaging. The implementation that is best is usually implemented as a default for the next release. So we had this A/B test where we wanted to see if casual players would prefer playing against bots or real users. So in one test case, we were spawning casual players in one arena against 99 bots. So like I explained before, our maximum value for arena was 100. So imagine a couple of thousand users in this test and a new arena for each player in this test. So during that period, our backend cost jumped for 10 times. So the minigame is still active in My Talkington 2, and so is the A/B test dimension, since I can't remember if we changed anything. So let's step it up. We have 1 versus 1. We have an arena with 50 to 100 players. Let's try an MOBA type arena battler. Slime Squad Arena, or as we called it at the beginning, Monster Time. It was our attempt at a multiplayer online battle arena, or MOBA type. In a genre where Brawl Stars was leading the charts, we tried to target a more mature audience than the one playing our Tamagotchi games, with snails as characters, a more casual gameplay, and an in-game transformation where for a short time the character would evolve to a more powerful form. The game unfortunately didn't make it past beta, but we did a lot of development, gameplay-wise and on the backend. Again, with Vertex for the matching, we would run the matching algorithm, this time based on the Guild Wars 2 player versus player algorithm. It's really nice. So they have a wiki page where the whole algorithm is explained, because this is they use this at competitive game, and players like to know what matches they get. So we implemented it similarly, and we introduced Photon and Quantum for communication between clients. Photon is a service that hosts infrastructures for multiplayer games, and our team was very impressed by it. Again, we updated our multiplayer infrastructure. We added a new matchmaker module that supports team matches, and reused the Google App Engine infrastructure for configurations. So in short, the client asks for opponents on the match server. The match server responds to 6 clients with the same room ID. The Quantum framework connects to the relay server, and the game starts. With Quantum and Photon, we reduced the number of server updates. For this game, the client is the authority, and the game actually runs on the phones. The matchmaker generates the room ID based on metadata that tells which client versions are compatible between themselves. Then Quantum takes care of synchronizing data between the clients, and automatically detects, for example, high ping, desync cheaters, because, for example, the data that is sent from one player in the match doesn't not match the flow of others. So we can handle these players, we can disconnect them and replace them with a bot for the duration of that match for a better user experience. The next match then would again reload opponent list of real users. Developing during development, developing the matchmaker was really difficult. We had to account for timeouts on the client, timeouts on the server, and we knew that the initial release wouldn't have a lot of players. So we also implemented fallback matching on the client, and the ability to fill one game with bots. So have in mind, this is a good example is our quality assurance team, when they're testing game features, they didn't have time to wait for 6 players to get matched, since no one was playing the game at the time. So this playing against bots was very useful for them to test just how the powers work, if the matches was overpowered, if the client guys fixed a bug on the scene. But we had also test session. So to avoid triggering this fallback that would match you with both bots during test session, we would just sit together, do a countdown aloud, and everybody would press start match at the same time. And then we could actually play against each other. And it was really fun at the time. So we learned that for development is essential to have local matches and playing against bots. While the matching algorithm was being developed by the backend team, the client team could go on with the game features. So Quantum, as a backend developer, this was the most interesting part I didn't work on. So Quantum is a deterministic game engine for Unity, and the client team was very impressed by it. So how does it work? Only input is exchanged between clients. So movement, firing, special actions. The Quantum plugin with the game, in combination with the game engine, then replace these input commands for each player directly on the client. The deterministic part works like this. Each move is predicted. Basically, replay the last input command until the relay server synchronizes all clients. This mechanism is used in a lot of games. If you're familiar with multiplayer games, you know how lag works. If an opponent or a teammate has a high ping, this results in jitter. The players then snaps at random positions on the map. Quantum also supports authoritative mode, authoritative server mode, where the game simulation is also run on Quantum servers. In this case, we would need to upload our gameplay code directly to their servers, and we were actually planning this for future releases. Once we have it all up and running, we started doing some company tests to see how the game was performing among us and if the other players are enjoying themselves. I only mentioned it vaguely for other games, but we did a lot of play sessions, and not only on multiplayer games, but we do this in our company for all of our games, either for a new release or either to test just a new functionality that might or might not get in the game later. So company-wise, with external partners or targeted audience. For Slime Squad Arena, we got to the next step, and we implemented support for downloading replays, analyzing them, analyzing the data generated, and generate heat maps like those in the picture. So with data for movement, damage done, kills, deaths, assists, and monster time use. We use these statistics for integration tests, so we know how the game changes over time, as well as bug fixing and deeper insight. For example, if we go back to Talking Tom Bubble Shooter, at the beginning, where the game was being still developed, we had a week-long company-wide tournament. All the company was playing, and since the game wasn't released, we were the only opponents. We were looking on our Slack channels, Skype at the time, who was still online for an after-work match. And our company game sessions were going great. We were checking the leaderboards first thing in the morning, but we didn't take into consideration that we knew each other, which of course made it more fun. We would just pick at each other. Oh, I'm better than you. I just won. I won you 3 times. I won you 4 times. But when we released the game, the starts were a little bit different. If you go back to Space Trails, we also had stress test sessions with the whole company and a web-based dashboard for displaying the longest trail and, of course, for bragging rights. We later found out that the web dashboard was displaying the players of only one arena, because we are a big company and 200 concurrent players would spawn 3 to 4 arenas. So we didn't find the best player overall during the stress session, but it was a fun play session anyway. Back to the heat maps. One good example is that we want the players to engage each other. The MOBA type games are more fun if you don't play alone. These maps show where the users spend most time and where players interact the most. So, for example, is a part of the map unused, just spawn a power-up on that location. For example, a part of the map can be easily accessed and people use to hide there or camp. Picture Brawl Stars and you have to collect the gems. We had a similar mechanic. Once you collect all the orbs, in our case, you would just hide in a corner and nobody would be able to get to you, and that team would automatically win. Well, this had to be fixed. So we removed or redesigned that obstacle, or added a power-up that a snail could just swoosh to that position. Also, powers, or one character has too high or too low kill rate, fix the power level, or rethink the character's abilities, and rethink also character abilities in connection between each other. And you can see in the pictures, the dots are multicolored. This represents each different playable character that we had in the game at the time. So now you know, we have a wider selection of games than just our super cute virtual pets and runners. You've seen how we upgrade our brand with engaging multiplayer functionality, how we reuse technologies and idea in different games, how we've grown and tried more complex multiplayer games and features, how with testing sessions and play session with the whole company, we learn, support each other, and in the end have a lot of fun. We still haven't given up on new games, on new multiplayer games, on different genre. We are working on RPG strategy game with MOBA elements coming out in 2021. So stay tuned, and you can try the first soft launch on Android if you scan the code. I'll get back on this slide after the last one. So that's it. If you have any questions, if you want to know more in detail what we're currently working on, you know, we are always searching for new teammates. Thank you.
Okay, thank you, Tomas. Let's see if we have any questions. Maybe I have a question for you.
Sure.
So you mentioned different games for different ages. How many categories of the players do you have? I mean, age-wise. So you obviously target different ages. You know.
All of our Tamagotchi games are COPPA compliant, so we for younger audience, but we don't sort players. We want to add functionality in each game that widens our audience. So the Tamagotchis are really simple. You can just pet them and take care of them. And we have mini games that maybe engage you in different ways. We don't have a strict policy from 5 to 10, from 10 to 12. We try with each game to reach a wider audience.
Okay. Yeah, thanks. So if we don't have any more questions, I would like to thank you for joining us for this virtual conference, and see you next year, Bob, hopefully in person.
Yes.
Okay.
Thank you, everybody.
Thank you. Bye.